Okay, so period 3, we had technical difficulties and yesterday's video that we were recording cut out now, so as you can see, there's no one here. This is fake. Do a pan of the room. There's no one, just this guy and some other random people taking tests and stuff. So anyway, this is video part 2, and I think what we were doing as the video cut out was doing a bunch of example problems. So could you please pick up from wherever you left off yesterday and take out a piece of paper, as I was saying, and start to do these problems using the chain rule. And then we're going to kind of do them together and talk them out. So you can pause the video and try all of them, and then watch as we do them together, or you can kind of just do it however you want. And this will probably go, this version will probably be faster because there's no one to slow me down. No students to get in the way of student learning. That's a joke. Alright, so how do we do this? Well, I've missed one.
Yeah, good. Yeah.
Okay, this is now part 3 because we had more technical difficulties. So part 3. All right, here we go. Chain rule in action. The chain rule says, as we'll recall from whatever, that the derivative of f of g of x is a derivative of f evaluated at g times the derivative of g. So to do this problem, it is important to recognize which is the inner function and which is the outer function. So I always rewrite my function in derivative-friendly form. So this is really x squared plus 1 to the 1/2. And when we apply the chain rule, we recognize that the outer function is something to the 1/2, and the inner function is x squared plus 1. So the derivative of this whole function is going to be the derivative of the outer function evaluated at the inner function times the derivative of the inner function. So the derivative of something to the 1/2 is 1/2 something to the negative 1/2. And then you multiply that by the derivative of what's on the inside, which is 2x. Okay. Then this I can simplify a little bit. The 2 and the 1/2 cancel, and so we get x over the square root of x squared plus 1. I always think it's a good idea to rewrite your final answer without any negative exponents. Okay, let's do another one. Again, here, the outer function is cosine and the inner function is 3x. So what is the derivative of cosine 3x? Well, basically what you have to say to yourself is, what is the derivative of cosine of something? The derivative of cosine of something is negative sine something, and then times the derivative of what's on the inside, which is 3. And so this is your final answer, is just negative 3 sine 3x. Okay. And then should I just tell the story? I guess I have to. So I had this calculus teacher in high school who was a terrible person, but he had a handful of catchphrases which have stayed with me. And one of them was whenever he did the chain rule, he shouted out this kind of catchphrase. So watch. So here again, the derivative. This function is some stuff to the 4th. So when you apply the chain rule, it's the derivative of something to the 4th is 4 something to the third, and then you go back inside the function to take the derivative of what's on the inside. And every time he applied the chain rule, he would shout out, back inside, so that you would not forget to go back inside and take the derivative. So then the derivative of 3x cubed minus 2x is 9x squared minus 2. So that's pretty much that. Okay, let's do some more. Here we go. Again, if I'm taking the derivative of tan of root, by the way, you should definitely try these first yourself. In the actual class environment, I gave sufficient time so that everybody did basically all of them, and then we went over them all. So you should be doing that. So what is the derivative of tan of root x? Well, first I'll rewrite it as tan of. Are you taping?
Yeah.
Okay, take 5. Take 5. We're about to take the derivative of this function. So yeah, outer function tan, inner function x to the 1/2. So of course you need to just know your derivative rules at this point. So the derivative of tan is secant squared. So when I go to take the derivative of this function, the derivative of tan of something is secant squared something back inside for the derivative of the something. And the derivative of x to the 1/2 is 1/2 x to the negative 1/2. And then you can write this out nice and pretty. It is secant squared root x over 2 root x. Okay. Okay, more. E to the secant. Well, okay, now the outer function is the e to the x function and the inner function is the secant function. So the derivative of e to the something is, well, the derivative of e to something is just e to the something. So e to the secant is going to be e to the something, and then back inside for the derivative of the something. And at this point, you should just know, more or less by heart, that the derivative of secant is secant tan. Okay, number 6 is a tricky one. You should definitely do this first on your own before watching what I'm about to do. But what you see is that this is kind of like a triple guy. If we write this out, which I definitely encourage, more or less insist upon, writing this out as this is really cosine of 6x to the 1/3. And so there's an outer function, which is something to the 1/3, and the inner function is cosine 6x. So here's the thing about the chain rule. It's recursive. So you just follow the rule. If you just think of the outer function as something to the 1/3 and the inner function is cosine, then we're just going to follow the rule. So here we go. The derivative is, well, what's the derivative of something to the 1/3? The derivative of something to the 1/3 is 1/3 something to the negative 2/3. And then we go back inside for the derivative of the something. So this is going to be times the derivative of cosine 6x. Now it just so happens that the derivative of cosine 6x also requires the chain rule. So what is the derivative of cosine 6x? Well, the derivative of cosine of something is negative sine something back inside for the derivative of the something. And so my final answer becomes, is that. So here we have kind of like a chain of derivatives. Okay, anyway, so this is negative 2 sine 6x over cosine 6x to the 2/3. And we just write it like that with no negative exponents. Okay, cool. Last couple of problems. F of x equals root. Oh, actually, let's do a different one here. Let's do root ln x. I like this problem better. So pause. No, you don't pause. If you're at home, pause and do this problem. Okay, what is the derivative? Oh, first let's rewrite it. Let's rewrite it as what it really is, which is ln of x, all of that to the 1/2. Okay, so when we go to take the derivative, we see, well, the derivative of something to the 1/2 is 1/2 something to the negative 1/2 back inside for the derivative of the something, which is 1 over x. And so again, I can write my final answer as 1 over 2x root ln x. Number 8 is kind of important. Though we are in the habit of writing it as sine to the 5th x, don't forget that that actually means sine of x to the 5th. So the outer function is the 2 to the 5th, and the inner function is sine x. And so the derivative is 5. The derivative of something to the 5th is 5 something to the 4th, back inside for the derivative of the something, which is cosine. And then if you want to write it in the standard way, it's just 5 sine to the 4th x cosine x. Okay, number 9 is also like a double chain rule kind of situation, although you don't have to think about it that way. So we rewrite it in its natural form. This is sine of x cubed, and then that whole quantity squared. And so the outer function is squaring, and the inner function is sine of x cubed. So the derivative of something squared is 2 something, and then you go back inside for the derivative of the something. So I'll even just write that. It's the derivative of sine of x cubed, whatever that is. Well, the derivative of sine of x cubed itself requires the chain rule, so that's the sense in which this is recursive. What is the derivative of sine of x cubed? Well, the outer function is sine, the inner function is x cubed, so the derivative of sine of something is cosine of the something, back inside for the derivative of the something, which is 3x squared. And so my final answer is like 6x squared sine of x cubed cosine x cubed. And you could do a trig identity there if you wanted. Okay, last problem. Now it's like a product rule. I need to do the product rule. So it's going to be the derivative of the first, and then I have to do the chain rule inside each of those. So the derivative of the first is 5.